some of the stuff gets kind of freakadelic. So if I don't get any questions, that's always as worrisome, but I'm an optimistic fool, so we have a couple things to finish up from section, where were we? 4.4. That's where we finally did L'Hopital's rule. I think a few people already knew about it. A few people were trying to use it back a few chapters ago. Good old the hospital rule. And this is a really nifty thing. It's kind of neat. It says that to evaluate this, so if this limit is in some indeterminate form, then the limit of this ratio is the limit of the ratio of the derivatives. And I kind of showed you how that has to deal with local linearity. Now obviously this assumes the functions are differentiable. If the functions are not differentiable, then it's pretty obvious this sucker's not going to work. Okay, I like it. The mistake a lot of people make is they love this thing. One big mistake I tried to address last time was I'm not doing quotient rule, right? Isn't that one of the worst rules? Don't do it when you don't have to. That's not the idea. I'm not taking the derivative of this quotient. I'm taking the ratio of each individual derivative. You guys with me? So don't make it worse than it really is. So let's try a couple of examples, and then I'll show you some other indeterminate forms we're not used to yet. My high-tech eraser. All right, so that's the idea. So let's see how this thing actually works in the wild. So let's see, for example, I like this one. It's kind of beautifully gross. I love it. This is a really good example of a problem I really couldn't do before. Is this in indeterminate form? Which form is it in? If you know it's indeterminate, you got to be able to tell me which form it's in. Which form is it in? 0 over 0. I love it. So it's in this form. I like it. So then I'm allowed to use L'Hopital's rule. So let me write this a little bit better. Just a little more ready. I always do this. I always put the little LH thing just to tell myself what the shit I'm about to do. And when I look back on my work, I can remember what the hell I did, right? It also helps me out a little bit when I'm grading your stuff, so I know what you're trying to do in case something goes weird. So what's the derivative of the top? Yeah, the 1 over 3 comes down to the what now? I love it. And the inside is just linear flip up a 1, so the chain rule doesn't show up. It's 1, so it doesn't show up. So that's the derivative of the top. What's the derivative of the bottom? 2x. I like it. Now here's where, well, okay. somebody will tell me the answer is 0. And the answer is not 0. Now, one, if you believe the answer is 0, maybe just sit there for a minute. I'm telling you the answer is not 0. But two, if you know the answer is not 0, can you see why somebody would say it's 0? Because they see 3 minus 3 is 0. They think to themselves 0 to something is 0. But what throws that off? I'm not picking on anybody, by the way. Everybody does this. This is to the negative power, right? So you can rewrite this as 1 is the only thing on the top. 3 comes down. X minus 3. Let me not forget my little limit. Is it still indeterminate? What part of that tells me there's no way in hell it's indeterminate? The top is 1. That's all right. So it is determinate, but it still isn't something. What is the answer here? When you plug a 3 in. Yes. I like it. So be careful. Infinity is not an indeterminate form. You can't do L'Hopital's again on that, because what's the only time L'Hopital's works? If I have an indeterminate ratio of things. That's when L'Hopital's works. Okay, I like it. Maybe. So let me see what kind of weirdness they get into. Oh, all right, let's do this. We'll leave that up there. To this guy. Yeah. What form is that in? And this is where misunderstanding about infinities comes into play. But just tell me, how do you tell what form it's in? Well, what do you get when you play on one end of this? It wants to go to what? What's natural log of x go to? 0. So what's 1 over 0 go to? Infinity. You guys with me? The reason they put the plus there is I know that it's positive infinity. So what forms is an infinity minus, and what happens to this guy? Same thing. Can you understand, and maybe more, some of you guys can do more than understand, you kind of believe this right now, that would be looked at as 0. Right? You can see that? I like it. Some of you guys are like, shit no, man. You can see that somebody might mistakenly say that's 0. Why is that wrong? Can anybody tell me why that is not necessarily, it could be, but it's not necessarily 0? All right, you ready? Here's a nice example. Where are you at, Jeff? Do you see how this by itself is going to infinity? And do you see how this by itself is going to infinity? Well, what's the difference doing? What's the difference doing? It's also going to infinity, right? So the fact that this is a difference between two things that go to infinity means whichever one's going to infinity faster, and again, that's why this will eventually be L'Hopital's. Now, if anybody's paying attention, why can't I use L'Hopital's directly on this thing? Say again? Nope, that is indeterminate. So this is a new indeterminate form. I cannot determine the answer because it's based on who's going to that infinity faster. Are you guys with me? So I told you we're going to do some more indeterminate. So the only ones we know so far were 0 over 0, infinity over infinity. Now we know infinity minus infinity is indeterminate. I like it. Yes?
Is it because it's not a ratio form?
Beautiful. So L'Hopital's only works if I have a ratio of two functions that is an indeterminate form. So how do I make two fractions become one fraction? Aw.
Combine it.
Two become one. Huh?
Combine it.
Yes, beautiful. Combine. Do it. Maybe combine them correctly. This is a really kind of nifty place where you can do something like cross multiply. I don't know if anybody has ever noticed this. Real quick, a side note. You don't even have to write this down. If I have 4/7 minus 2/5, I can just say that's 20 minus 14, 6 over 7 times 5, 35. Done. Beautiful. That isn't really cross multiplication, but why does it work? Do the bottoms have shit in common? Do they have anything in common? Nothing. 7 and 5 have nothing in common. So he needs a 5, so it's 5 times 4. He needs a 7, 7 times 2. And the bottom is going to become 7 times 5. So how do I do this one? X minus 1 times that, minus that times that, all over that times that. Now, you get the same answer, just do it, the old-fashioned way, but still. It's a beautiful way to subtract or add any fractions anywhere. Now, what form is that in? Zero over zero. I love it. So that is a ratio that I'm having the limit taken of that is in that indeterminate form. I could apply L'Hopital. Go ahead and apply L'Hopital's rule. See where you get. The bottom is going to be exciting. So the top becomes what? Where do you get on the top? So 1. We're taking derivatives now, right? So cool. So 1, that goes away. Oh, 1 over x. What's the bottom involve? Product rule. Derivative of natural log of x is 1 over x times this, plus ln x times the derivative of that. Well, the derivative of that's just 1. Let's clean this up a little bit. How do I clean this up a little bit? It's kind of like the worst offender in here. The bottom, I can distribute that, right? But what's kind of like the worst thing in this? It's a big-ass fraction with little-ass fractions inside. So let's kill that little-ass fraction so I don't have fracception, right? Fractions inside of fractions. And I got to spin the little thing, see what level I'm in. So if I multiply top and bottom by x, I get x minus 1 over x minus 1 plus x, natural log of x. So I just multiply top and bottom by x. Why am I allowed to do that? What's the only value I couldn't do that for? Multiply top and bottom by x. Why am I allowed to do that? The only value I could not do that for is, I could do it. What can I not multiply top and bottom by? The only number I can't do that with. I love you guys. You're all like, 4? What's the only number I'm not allowed to multiply top and bottom by? I can multiply a fraction by any number I want to except 1. 0, right? And y is not really a problem here because I'm supposed to be really, really close to 1. So x can't be 0 close to 1. I like it. I mean, it's a little tiny point to make, but still it's important to realize why I'm allowed to do what I just did. What form is that in? Yes, and just to make sure, does everybody see how we can see what form it's in? You just plug the 1 in, right? And if you plug a 1 in, you get 0 over 1 minus 1 is 0 plus 1 times natural log of 1 is 0. So it's still 0 over 0. So what am I allowed to do? L'Hopital's again. So you can do L'Hopital's multiple times, but you can only do it if it's still in indeterminate ratio form. It kind of makes sense. If it's not indeterminate, of course I stop, because that means it must be determinate. I must be able to determine the answer then. Why would I do more shit to it if I could just stop? Plus, L'Hopital's, it could totally make it the wrong answer if you do it when you're not allowed to. So we got to do L'Hopital's again. Yeah. Little Howard Dean there. Let's do L'Hopital's. Yeah. So if I do L'Hopital's again, I'm going to do the top. Just to be nice, I did half of it. Well, the bottom's not that bad, hopefully. Is that cool? The derivative of the top is 1. What's the derivative of the bottom going to be? Here, I'll do this one. So it's 1. The negative one goes away. How do you do the derivative of x? Natural log of x. So x, natural log of x. What's its derivative? It's a what? What rule? Product. So derivative of x is 1, so ln x plus, leave x alone, times its derivative of ln x, 1 over x. So I get ln x plus 1. Is that still indeterminate? I know it can't be because the top's 1. But what do I get on the bottom when I plug a 1 in? Yeah, 2, right? So this becomes 1/2. That's neat. Okay. So you could use L'Hopital's multiple times within a problem. You just stop when it's not indeterminate. Number one, the most important thing is L'Hopital's isn't guaranteed to work if it's not indeterminate. Secondly, again, why would I go further if I can determine the answer? I like it, maybe. All right, one last type that's kind of new to us. I think they only do one more type. Well, yes, okay. So here's something that's kind of funkadelic. So more indeterminate types. This is indeterminate. This is actually one of the most famous indeterminate forms. This kind of form is where E came from, to be honest, the number E. Why is that indeterminate? 1 to any power is 1, right? Well, no, that statement is true. 1 to any power is 1. But where would this have come from? For example, this would have come from a problem like this. You guys see that? Because the inside is going to 1. I'm sorry. Let me write that the right way. There we go. The inside's going to 1. And the outside is going to infinity. Does the inside ever get to 1? Does this ever get to 1? The limit of this is 1. Is that cool? But does it ever get to 1? Well, does the limit ever let x get to 0? No. So does this ever get to 1? No. That's the trick. So looking at this as if it's 1 is wrong. This would have come from a limit. And it never is 1. That's why this limit might not equal 1. You might look at this and say, well, that's 0. No, we already saw how that's not necessarily 0. You might look at this and say, well, that's 1. No, it depends on who's going to which thing faster, which is why L'Hopital goes, oh, maybe I could do some shit. But what's really wrong with that, if L'Hopital wants to try to do some shit, what's wrong with that? Again, same thing that was wrong with this one, is not in the ratio. Stupid thing. Oh, shit. So who remembers how we handled, or we were supposed to handle, a derivative of something like x to the 6x? What did we use to help us do this derivative? Anybody remember? It was on the last test. How do I do that derivative? What do I have to use? What's wrong with that sucker? Why can't I do the derivative of that directly? If it was x to a number, all day long. If it was a number to x, all day long. That's both at once. Oh, shit. There's no rule for that. So how did I break that bad boy up? What did I use? What do we always use when the power is kind of a problem? What's the only function that brings the power down? Natural log. So if you take natural log of both sides, I could do implicit differentiation. Oh, shit. So don't we have a very similar issue here? We have two kind of different things going to different values, and I need to break them apart somehow. So let me call this y. This is how you do anything in this form, and there will be other things. A function to the power of another function, the limit, this is how you do it if it's in an indeterminate form. Okay, I like it. So, if I take natural log of both sides, yeah, there. Is that cool? Right? Let me go. All right, let me stop. Is everybody cool with just that? Here's, all right. Let me write what I got so far over here. There's two ways to do this. If I took the limit of this guy, will that be the answer? No, because I need to know what y goes to. So if I figure out what this guy goes to, I have to raise e to it to figure out what y goes to. So you could either do this. You can just take this piece. Where to go? Yeah, 0. I forgot which problem we were doing. And then put this in. But then I have to remember that I'm going to have to raise e to it. But in general, one of the things that very often as teachers, we don't just tell you this. It's something that sometimes you have to realize. We're going to do this problem in a minute, but just to put this on the side. If I have, you can do it, Jeff. I don't know. X to the 2x. Can I rewrite that as e to the natural log of x to the 2x? Is that all right? Why is that okay? Let me just ask it like that. Because what would these do? Cancel. So that's right. And then can't I bring that down? Yes? Yes? So I can always rewrite x to the 2x as e to the 2x ln x. So I could write a to the b as e to the b natural log of a. That doesn't show up like 50% of the time, but it shows up often enough to be a real good thing to just know. Okay, the big thing here is to realize that when part of the problem is I've got function of x with a function of x power, logs want to come in and help. Logs are like, dude, I got this. I can make that not a power anymore for you. It sounds like that would be easier to look at. And what is good about this now that you might not yet kind of realize? What was the problem with this? It wasn't in ratio form. So, but what does this limit now look like? If I just force it to look a little bit, put the natural log on the top, now it's ratio form. And of course, what's in the form of specifically? 0 over 0. I love it. So finish that out. Go ahead and do L'Hopital's to this bad boy here. And my point, this is where you've got to make the math your own. You can either write this e here, or you just attack this shit and remember to raise e to what you get later. So it depends on how much you can kind of trust yourself. What else did I tell you? Oh, good. Yeah, this becomes really nice, right? What's the derivative of ln 1 plus x? One over 1 plus x. And the derivative of x is 1. So what's e to this thing? What's this thing? X equals 0, so that becomes 1. E to the 1 is e. So this is the definition of e. This is the boring place e comes from, to be honest. But it's still kind of freaking nifty. The limit, as x goes to 0, of 1 plus x to the 1 over x is e. That is part of the reason why we gave it a symbol. Is it's the balancing act between this going to 1 and this going to infinity. It balances out to be this number e that freaked people out, so they gave it a symbol. Same way that pi freaked people out. Right? Take the circumference of any circle divided by diameter, you get the same damn number. It just freaked entire civilizations out. They thought it came from God. You know. Okay, maybe. E was discovered by Euler, but he didn't give it the letter E because his name starts with an E. It was just the next letter. He was using all these letters for different shit he found. So it just happened to be the next one. This is like one of his most famous discoveries. Just happens to start with E. Oh well. So what does this work for? So the one we just looked at was 1 to the infinity. What about 0 to the infinity? Would that be an issue? Now, this is kind of an evil question, but this would not be indeterminate. Stay with me now. Why would this not be indeterminate? Because if this inside is going, whatever this is, if that is going to 0, eventually it's less than 1. Stay with me now. This is kind of nifty. Come on. If the inside's going to 0, eventually it's less than 1. What happens when you raise a number less than 1 to a really giant power. What happens when you multiply numbers that are less than 1? The result gets smaller. You guys with me? Half of a half is a quarter, right? So if this was a half and this was 500, that's basically 0, right? So this is not indeterminate. This will actually just be 0. So that's not indeterminate. So what else is indeterminate? What about, kind of the other way, what about 0 to the 0? I tell my students this in like Math 90. When we learn like anything to the 0 power is 1, then I have to say, except 0, 0 to 0 sucks. It's worse than undefined. And now you see it is worse than undefined. It means you got a lot of shit to do. Maybe. You guys. But what I do for this? The same damn work we just did for this. Because it's still function to a function going to 0, 0. It's just that I need to know what form is indeterminate. What form do I have to do this for? This form, and they tell you one more form. Yeah, no, we already did that one. Yeah, this one. If I turn this sucker around, infinity to the 0. Anything to the 0 power is 1, right? But does the power ever get to 0? No, and the insides get to it. So if the inside gets really big a lot faster than the power gets to 0, the result actually might be infinity. Or the result actually might be 1, or it could be somewhere between like E. I'm hoping some of you guys, I know this might feel a little overwhelming, but we've done this kind of natural log thing before for the same exact reason we're doing it now. But this is really kind of nifty shit. Somebody must have been wondering about this thing before when you learned about 0 power. And now we can actually analyze it better. Okay. That's enough of that. That finishes up section 4.4. That's all about L'Hopital's rule. And those are the 3 brand new, and there's the other one we did earlier. Those are the brand new indeterminate forms that we can still do stuff with. All right, now I want to shut up for a little while, which is probably what some of you guys wanted to tell me, but I'm going to let you guys, I'm going to let you guys work on this, preferably with somebody else. That always makes things go better, but if you're a lone wolf, that's fine. Your army of one.